is an equation containing the derivatives of a function So everybody is clear about what is the derivative? Yes? Okay. Derivatives of a function along with the function itself and some arbitrary constants. Okay. Like for example, if we have this equation dy by dx is equal to x. So this can be said as a differential equation. Can you solve this equation? Any idea how to solve this? How? Integration. So how will we integrate? Yeah. So the next step would be dy is equal to x dx. Then we'll integrate both the sides, and then we can get the solution, right? So, we'll in this chapter we'll learn about all the different types of differential equations, how to solve them, and what are different methods to solve these equations. Okay. So first of all, you must be clear about two different terms which are used here. Oh, everybody is written this? Okay. So two different terms which come over here is, first one is the order, and then we have the degree. So these are the two terms which will be used here: order of a differential equation and degree of the differential equation, right? So if I write this equation like this, d2y upon dx square plus dy by dx plus x is equal to 0. So if this is the equation, can you tell me what is the order of this equation? 2. Why? Because we are having a second order derivative over here, right? So the order of this equation will be 2, right? And can you tell me what is the degree of this equation? 1. Why? Yeah, highest power of the order is 1. So what if we have square over here? Then what is the order? Order is still, degree is still 1, right? So what is the degree? This is the highest power on the highest order derivative. Okay, so write down the definitions for both order and degree. Order is the order of the highest order derivative or highest derivative present in the equation. So it is the order of the highest derivative present in the equation, right? And what do we mean by degree? Yeah. So degree is the degree of or power of the highest order derivative present in the equation. Okay. So let's do some questions on order and degree. What if we have d2y upon dx square plus dy by dx is equal to cot x? So here the order is 2 and the degree is 1. So in this case, order is equal to 2 and degree is equal to 1. What if we have sine of d2y upon dx2 whole square plus, let's suppose x is equal to dy upon dx. So what is the degree over here? Why? Degree is 1 because dy by dx की power 1 है. That's why? No. So what is the degree? So degree in this case is not defined, right? Because this higher order derivative is coming under this function, sine function. So this is a composite function, right? Such functions are known as transcendental functions. You know, transcendental functions, sine, all the functions which are not algebraic are transcendental functions, right? So this d2y upon dx2 which is a second order derivative. This is coming under sine function. Therefore, the degree is not defined. So write it down. The degree is not defined in this case. And what if we have tan of so what is the degree of this equation and order of this equation? Order 2, degree 1. Why? Exactly. Right. So you have to see it very carefully. In this case, we couldn't do sine inverse over here on both sides, because a sine inverse has to be done if this function is whole inside one bracket, right? But in this case, it can be done, right? We can do tan inverse on both sides, and what we'll get is d2y upon dx2 is equal to tan inverse x. And what is the order of this equation? 2, and the degree is equal to 1. Correct. So here, write down order is equal to 2 and degree is equal to 1. Okay, can we have an equation like this? d2y upon dx2 to the power 3 by 5, or let's suppose 6 by 5, plus dy upon dx is equal to x. Is the degree for this equation defined? No, because the degree cannot be fraction. Okay, so degree in this case not applicable, because this can't be a fraction. Okay. Next case is d2y upon dx2 square plus 1 to the power 1 by 2 is equal to dy upon dx. So what is the order and degree for this equation? Order 2 and degree also 2. How? Yeah. So what we can do here is squaring both sides, right? And this will be, if we square both sides, this 1 by 2 will be 1, right? So in the next step, I'll write. Yes? Yes. In this case, you will have this thing, na? X minus dy by dx. So there will be a lot of terms over here. dx dy by dx to the power 5. Then you will have to apply all the binomial. Yes. 30 कैसे हो जाएगा? Okay, 6. Yes, that can be done. But what I was trying to tell you that this can't be a fraction. That's the thing which you need to remember. Okay. Now in this case, अगर squaring both sides करेंगे तो क्या हो जाएगा? d2y upon dx square dx2 plus 1 is equal to dy upon dx. Now this is also square and this is also a square, right? So order is 2, and because the power of this second order derivative is also 2, therefore degree is also 2. So in this case, order is also 2 and degree is also equal to 2. Okay. Next is d2y upon dx2 plus e to the power dy upon dx plus y is equal to x square. So can we tell what is the degree of this equation? No, because this is a transcendental function, right? So degree of this function is not applicable. So whenever we have this derivative inside, let's suppose sine, dy by dx can be written like this, y dash. Everybody knows that y dash is same as dy upon dx. So if we have sine of y dash or e to the power y dash terms like this, or ln y dash, so the degree is not applicable in such cases. Okay. So similarly, if we have root 1 minus x square dy plus root 1 minus y square dx is equal to 0. So can you tell me what is the degree and the order of this equation? Degree 1 and order also 1. How? So we can divide whole equation by dy by dx, right? By dx, if we divide this whole equation by dx, this will remain 0. This is simply just like this, and this will be dy upon dx. So we just have a term of dy by dx, no second order, no third order derivative. So the degree is also 1 and the order is also 1, right? So this is all about the degrees and the order of differential equation. Now we'll move on to the next topic, which is formation of differential equations. So I will start writing the short form over here, DE. I hope it's clear. Differential equation. So there are two parts in this chapter. This is a very short part, formation of differential equation. If you're given a function, right, or if you're given an equation, you have to form the differential equation out of this, right? But the major part of this chapter is you are given a differential equation and you have to determine the function, right? That's the major part, also mentioned in the NCERTs, right? We have a lot of exercises over here, and this is a very small part, so let's cover it out first. So write down write down a statement over here. Given an equation containing arbitrary constants, given an equation containing arbitrary constants, it is possible to get a differential equation whose solution is the given equation. Okay. And the next thing is, how do we get the differential equation? So write it down. Differentiate the given equation. Number of times so how many times do we have to differentiate? Any idea? Yes? Yeah. This number of times should be equal to the number of arbitrary constants. Okay. So the purpose will be to eliminate all the arbitrary constants, right? And then get a differential equation. Okay. So first, so everybody is aware of coordinate geometry, like parabolas, ellipse. You are all clear? So what is the standard equation of the most standard parabola? You know it. Y square is equal to 4ax. Good. So the first question here in formation of differential equation is, find the differential equation for y square is equal to 4ax. Can you do it? Just try it out. Find the differential equation for y square is equal to 4ax. So how many arbitrary constants are there? Just one, which is a. So this is the only arbitrary constant over here. Done? Okay, what is the equation? Y square. Okay. So what to do first? First we'll differentiate this equation. So what are we getting? Y dash 2y dash. Because of the chain rule, the differentiation of y square will be 2y, and then we have to differentiate y again. So we can write y dash or dy by dx. In the last step, I'll make it a dy by dx. This is equal to 4a. So y dash is equal to 2a. So how to eliminate this a? Yeah. So put the value of a from here in this equation, right? So y dash is equal to y square upon 4x. Okay. And also we have a 2 over here, 2 into a. So this y and this y can cancel out, right? Why can we cancel this? Because y is not equal to 0, right? Since y is not equal to 0, we can cancel this. So what do we get is y is equal to 2xy dash. So if we write this in dy upon dx form, so we get 2x dy upon dx minus y is equal to 0. Everybody getting this? Okay. So write it down. The next question is, y is equal to a e to the power x plus b e to the power minus x. So this is also a very simple one. Just try it out. So how many arbitrary constants do we have? 2. So we'll have to differentiate it 2 times. Got it? Okay. So what we'll do is, we'll differentiate it the first time. What do we get? Y dash is equal to a e to the power x. And what is the differentiation of e to the power minus x? Minus e to the power minus x. Minus b e to the power minus x. We'll differentiate it once more, right? So y double dash is equal to a e to the power x plus b to the power minus 6. Now this is a very simple one. We don't have to do anything. We know that y double dash is exactly the same as y. So what will be the differential equation? That y double dash is equal to y. Because if we compare these two, they're exactly the same. Okay, so the equation will be d2y upon dx2 is equal to y. Okay, so this is the answer. Next is ax square plus by square is equal to 1. So form the differential equation over here. Okay, if you want to represent this as a points on the plane, what will be the form? What will be the shape form? How will we get circle? Ellipse? Yes. Because the coefficient of x square and coefficient of y square are different. Therefore, we'll get an ellipse. Done? Okay. So we have two arbitrary constants over here. So we'll have to differentiate it two times. So differentiated the first time, we get 2ax plus 2by, then y dash. Differentiation of 1 is 0, right? So what did you do after this? इसके बाद directly differentiation like this? No? Then? Okay, good. So this 2 and 2 cancel out. Then we get by y dash is equal to minus ax, and y dash upon x is equal to minus a upon b. So what help did this step do over here? So we have all the constants over here. If I differentiate it once more, this whole thing will vanish, right? So if we differentiate it once again, we'll apply u upon v rule, quotient rule over here. So u upon v rule says that this is equal to, in the denominator we have v square ऊपर v u dash minus u v dash, right? So this is equal to 0, this is for sure. The denominator we have x square, right? And this function as it is, y dash minus into the differentiation of, okay, this function as it is, sorry, x as it is, and differentiation of this numerator. So how to do the differentiation of numerator? Again, product rule. So we have y dash square, right, plus y into y double dash, right, minus 1 into y dash is equal to 0, right? So the final equation, can we cancel this x square? X square can be multiplied with 0. So what do we get? X d2y upon dx2 plus dy upon dx whole square plus x into y into d2y upon dx2 minus y into dy by dx is equal to 0. So what is the order of this equation? 2, and the degree is 1. Okay. So write down the fourth question. Y is equal to C1 e to the power 3x plus C2 e to the power 2x plus C3 e to the power x. So we have 3 arbitrary constants over here, right? So this is a bit tougher because we have to differentiate it 3 times. So what will be the first step? Differentiate it right away. Then, yeah, exactly. Divide the whole equation by e to the power x or multiply by e to the power minus x. Okay. The use of that will be that we'll get this C3 alone, right, without any function. And if we differentiate it, it will become 0. Okay. So we'll do it step by step. C2 e to the power 2x plus C3 e to the power x. So divide equations by e to the power x. We get y e to the power minus x right. Done it. So everybody did it like this, right? First you have this equation. What I did is divide the whole equation by e to the power x. So this becomes e to the power minus x, and this is e to the power 2x, right? Because it was e to the power 3x at first, and this is e to the power x, and then we have the constant over here. If we differentiate, this part becomes 0. This part cancels out. This becomes C2 e to the power x, and this is C1 e to the power 2x into 2, right? Because of the chain rule. And here we have the product rule, right? Differentiating the first one, y dash into e to the power minus x. Differentiating the second one, keeping the first one constant, minus y e to the power minus x, right? And this one, we've done it. Again dividing by e to the power x. This one cancels out, and this is again a constant, so we can cancel out. Then the fifth step will be again divided by e to the power x. So we'll get minus 2 y dash minus y e to the power minus 3x plus e to the power minus 3x y double dash minus y is equal to 2c1. And the sixth step will be again differentiating. So differentiation of this will be, first I'll differentiate this part, okay? So minus 2 e to the power minus 3x y double dash minus y dash, okay? Then differentiate this part, minus 2 y dash minus y into, I'll make it plus 6. Sorry. Clear? Okay. Plus e to the power minus 3x. Then this will become the third order derivative. Y triple dash minus y dash minus 3 e to the power minus 3x y double dash minus y. Okay, this was y dash, right? Hmm. Everybody's getting the same answer? Same? Okay. So what will be the next step? Segregate all the terms, right? So collect all the terms containing the third order derivative, then the second order, then the first order, then the only y value terms. Okay. So just write the final step. d3y dx to the power 3 into e to the power minus 3x plus d2y upon dx2. So we have minus 2 e to the power minus 3x minus e to the power minus 3x minus 3 e to the power minus 3x, right? Then the y dash terms, dy upon dx, this will be, what all terms are we getting? This one and this and this last one. So minus 2 e to the power minus 3x, okay, this will be plus here, minus, okay, plus 6 e to the power minus 3x, and this term minus, this is also plus, and the only y term, this one, is equal to 0, right? So this e to the power minus 3x will be common from all of these, and we can cancel this out, and this will reduce to a very simple equation. What is the final equation? d3y upon dx3 minus 3, this is 6. Okay, I was saying that can't we take this e to the power minus 3x common from all this, right? We can cancel it out. So we'll get d3y upon dx3 minus 6 d2y upon dx2, right? Plus 11 dy upon dx minus 6y. This is the answer everybody is getting. Next type will be, you are given an equation. Let's suppose, okay, do it by question only. You are given an equation y is equal to c1 e to the power 2x plus c2 e to the power x plus c3 e to the power minus x. This is a similar question to the previous one, and you are given that this is a solution for d3y upon dx2, sorry, dx3 plus a d2y upon dx2 plus b dy by dx plus cy. So if you know that this is a solution for this equation, what to do? Put the value, right? So we'll put the value of y over here. First we'll differentiate it 3 times, and we'll put the value over here. Then 2 times, put the value here. Then single time, put the value here, and then put the value of y straight over here. So you have to tell me the value of, so if this function is a solution for the differential equation given by this, okay, so tell me the value of a cube plus b cube plus c cube upon abc. Can you do it? So this function y is equal to c1 e to the power 2x plus c2 e to the power x plus c3 e to the power minus x. This is a solution for this differential equation. Find the value of a cube plus b cube plus c cube upon abc. Anybody is getting answer? Minus 1 upon 4. Good. Correct answer. So let's solve this. First, this is given as y. Let's see the value of y dash, which is dy upon dx. It will be 2c1 e to the power 2x plus c2 e to the power x minus c3 e to the power minus x. Okay. y double dash 4 c1 e to the power 2x, right? This one is a constant 2c1. Differentiation of e to the power 2x is e to the power 2x into 2. So we get 4c1 e to the power 2x plus c2 e to the power x plus c3 e to the power minus x. Okay. Y triple dash 8 c1 e to the power 2x plus c2 e to the power x minus c3 e to the power minus x. Okay. And you are given that this equation satisfies the differential equation. So all of this will satisfy, right? Because these are the derivatives of this equation only, this equation itself. So let's put the values of all these derivatives over here. Okay, this will become a bit tedious task. So let's try. D3 will be 8 C1 e to the power 2x plus C2 e to the power x minus C3 e to the power minus x, right? Plus a times the second derivative, which is 4c1 e to the power 2x plus c2 e to the power x minus plus c3 e to the power minus x, plus b times we have the first derivative, which is 2c1 e to the power 2x plus c2 e to the power x minus c3 e to the power minus x, plus c times c1 e to the power 2x plus c2 e to the power x plus c3 e to the power minus x, and this is all equal to 0. So what would be the next step? Yes, next step is multiplication. Okay, that can be done. Or yeah, just take the common factors. As we can see, we have e to the power 2x over here, here, and here, right? But we don't have any e to the power 2x over here, right? Neither do we have e to the power x nor e to the power minus x, right? So just write down that e to the power 2x, 8c1. What are all the terms combined with e to the power 2x? 8c1. Yeah. And let's take c1 also common, right? Because that is also coming common. So c1 into e to the power 2x, we are getting 8 plus 4 times a plus 2 times b plus c, right? Plus c2 e to the power x. So what all terms are coming with c2 e to the power x? First just 1, then plus b plus c, and with c3 e to the power minus x, we are getting minus 1 plus a minus b plus c. Any other terms? No. And this is equal to 0. So what does this imply? This implies that all these 4 terms are separately equal to 0. All these 3 terms, sorry, right? That 4a plus 2b plus c plus 8 is 0, which gives us the first equation, which is 4a plus 2b plus c is equal to minus 8. The first equation. The second one will be a plus b plus c is equal to minus 1. Third equation is a minus b plus c is equal to 1. So 3 equations. We can simply solve these two, right? So what will we do? Subtract these 2 equations. Subtract 2 and 3. You will get the value of b is equal to minus 1, right? Subtracting, you will get 2b is equal to minus 2. So b is equal to minus 1. Put this value in any of the equation. So here you get, if I put this value over here, we get a plus c is equal to 0, which means a is equal to minus c. Put all these values in the first equation. What do we get? 4 times a and b is minus 1, so this becomes minus 2, and c is minus a is equal to minus 8. So 3a is equal to minus 6, a is equal to minus 2, b is equal to minus 1, c is equal to plus 2. Okay. So what value do we need? A cube plus b cube plus c cube upon ABC. Now see, a cube is equal to minus c cube. These two will cancel out. No need to calculate these two. So b cube is minus 1 upon a into b into c. So this gives us the answer minus 1 upon 4. Clear with everyone? So what we did is, we saw that the coefficients of e to the power 2x, e to the power x and e to the power minus x are not in the RHS. Therefore we equated all the coefficients from the LHS to equal to 0. So the next part is also how to find the order and degree, right? But in this case, I will not mention the differential equation. You have to judge from the original equation, original function, that what will be the order and the degree of the equation. Like let's suppose if we have a question like this, dy, okay, no dy by dx. So first question, y is equal to c1 sine 2x plus c2 e to the power 2x. So what is the degree of this equation? Order will be 2, degree. So in this case, you can easily tell the order because we have two constants over here, two arbitrary constants, right? So if we'll differentiate it, how many times do I have to differentiate it? 2 times. Therefore the order will be 2. How to find the degree? You will have to differentiate it first. You will have to eliminate this arbitrary constants. Then you can find out the degree. Okay. So here, if you're just asking the order, this will be equal to 2. Okay. Can you try to find out the degree? Just try. Any guesses? So we have y dash is equal to 2c1 cos 2x plus 2c2 e to the power 2x. Y double dash is equal to minus 4c1 sin 2x plus 4c2 e to the power 2x. Okay, will there be any power on this y double dash? I don't think so. As you can see, it's a simple linear equation, right? We have to eliminate c1 and c2. How will we do that? Just subtract these two equations, but no multiplication will be done, right? We don't need any multiplication. We just have to eliminate the c1 and c2. What we can do is multiply this equation by 2 and then subtract these two equations. So we'll get the value of c1, right? And how to get the value of c2? Let's suppose I multiply this by 4, right? Multiply it by 4 and then add the first and the third equations, right? This will cancel out. If you multiply it by 4, this will become 4 and this will cancel out. I'll get the value of c2 itself. But since there will be no power on, no exponent on y double dash, therefore the degree is also equal to 1. Okay, so order is equal to 2 and the degree will be equal to 1. Let's do the next question. What is the order of differential equation formed from the circle So we have circle with constant radius. So you have to determine the order here. So there are two ways to do this question. Just tell me by solving it by either one of them. Order is 1. How? What? Okay, what is the standard equation? Plus? But I just said that it has constant radius. The center could be anywhere, right? Center could be a arbitrary constant. The equation which you are mentioning, that is only in the case for the circle which has a center 0, 0, right? The center could be anywhere. The only thing which is mentioned is that the radius is constant. Okay. Kitna? Okay. So tell me, what is the answer? Is it 1, 2, or 3? 2? 3? So how are you getting 2? X square plus y square plus 2gx plus 2fy plus c is equal to 0. Yes. So okay, if we differentiate it, then so can you tell me from here how many parameters do we have? 3. Just see that the constant, the radius is constant over here. What? 2 parameters नहीं होने चाहिए. If we have this, I can rewrite this equation like this: x minus, let's suppose, h whole square plus y minus k whole square is equal to r square. Right? The radius is constant; it will be eliminated. Now see, we have two variables over here, right? Two constants over here, h and k. Right? You know the parametric form for the circle. What are the parametric coordinates? Huh? R cos theta, R sin theta. You all know that, right? So here R is constant and the other parameter would be theta, right? So we have to eliminate how many parameters over here? 2, right? So you have to see the simplified form of this equation, right? The most simplified form. If he has mentioned that the radius is constant, you have to see only the 2 parameters, right? If you're given a general equation, let's suppose like this: ax square plus by square plus 2gx plus 2fy. So what is this equation called? General equation for any conic, right? 2hxy plus c is equal to 0. So how many parameters do we have over here? We have a total of 6 parameters. But unless it is mentioned that this thing is constant or that thing is constant, we have to see that constraint as well, right? And since we know that the radius can be written like this: root g square plus f square minus c is equal to r. So if this is constant, we can eliminate some of the variables from here also, right? So if one thing is constant, despite of getting 3 parameters, despite of getting three arbitrary constants, we can convert one of them into the other two. Are you getting it? If we convert one of them into other two, the number of effective parameters will be equal to just 2. So the order for this equation will be 2. Okay. So the order for the circle with constant radius, this will be equal to 2. So next part, next question, write down y is equal to c1 cos 2x plus c2 cos square x plus c3 sin square x plus c4. So if this thing is not clear from this question, the circle, you will get the idea from this one very clearly. So by seeing the question as it is, can you tell me how many arbitrary constants are there? 4. We also have a c4 over here, right? So we have 4 arbitrary constants. So what should be the order? 4. But the order is not equal to 4. And you have to figure out why. So the options for the order are, let's suppose 1, 2, 3 and 4. 3, how? So we have 4 arbitrary constants, C1, C2, C3 and C4. But I am saying that the order is not equal to 4. Explain how and tell me what is the order except 4. So it will involve a bit of trigonometry, if you're aware of that. You have cos square x, you have sin square x, and you have cos 2x. Are you getting any clue from this? Yes, how? Okay, cos 2x is equal to cos square x minus sin square x. One is that thing. You know, we derived, you must have derived 2 formulae from that formula only. Like if we have just cos square x, how can you write this in terms of cos 2x 1 plus cos 2x divided by 2, and sin square x can be written as 1 minus cos 2x divided by 2. Everybody is clear? How do we get this formula? Because we know that cos 2x is equal to cos square x minus sin square x. It can be written like this: cos square x, 2 cos square x minus 1, or 1 minus 2 sin square x. So from these two we get this formula. Can we put this values over here? Right? What did I want to do is that I want to convert these two into cos 2x, so that I can simplify this equation even more. So what do we get as y is equal to c1 cos 2x. I left this just like that, plus c2 1 plus cos 2x upon 2 plus c3 1 minus cos 2x upon 2 plus c4. Any idea now what will be the order? 2 will be 2. Let's see how. So y is equal to, let's segregate the terms for cos 2x. We get c1 plus c2 by 2 minus c3 by 2 plus c1 by 2 plus c3 by 2 plus c4. I can take this at some other constant c1, let's say capital C1, and this is capital C2. So the final equation which we get is cos 2x into capital C1 plus C2 is equal to 0. Clear to everyone? Yes. So how many effective arbitrary parameters or arbitrary constants are over here? Just two. First is this one, the second one is this. So therefore the order for this equation is equal to 2. Clear? So just don't judge by seeing the arbitrary constants in the starting only. You have to do a bit more manipulations than that. Next one is y is equal to x plus 1 plus y dash plus y dash square upon 2 factorial plus y dash cube upon 3 factorial, so on. Any doubts? Doubts? So tell me the order of this equation. So what will be the order of differential equation when formed out of this given equation? Hmm? 1. Okay. How? Minus. Right. So for this question you need to know the expansions, right? If you have e to the power t, the expansion for it is 1 plus t square upon 2 factorial t cube upon 3 factorial. You're aware of all the other expansions? What is expansion for sine t? Yeah, odd powers. T minus t cube upon 3 factorial plus expansion for cos t 1 minus. So alternate plus and minus sign in these cases. Then ln of 1 plus t. Anyone? T minus t square by 2. So just get rid of the factorials over here. Plus t cube upon 3. Okay. So these are the most important expansions which you need to remember. So these expansions helps a lot in the limits. If you remember, if you want to calculate the limit for e to the power t minus 1 upon t, you know what is this? When we have limit t tending to 0. What is this limit? This is equal to 1. This is a standard limit. How to find it? Just subtract 1 from here and divide it by t. And when you put this limit t tending to 0, this will become 1 and these all will become 0. Negligible. And similarly for sine t upon t, divide this by t. This is 1, all are 0. Cos t, we have the limit which is 1 minus cos t upon t square. Limit t tending to 0, right? So what is the limit for that? Half. Remember, limit t tending to 0, 1 minus cos t upon t square. This is equal to half. So how do we get this one? From this expansion. And similarly, standard limit ln 1 plus t upon t, this is also equal to 1. Okay, this is a bit off topic. We just need this expansion for that question. So we'll get y is equal to x plus e to the power y dash. So how will you solve this? We can take y minus x over here. This is equal to e to the power y dash. And taking log on both sides, natural log, we'll get ln of y minus x is equal to dy by dx. Now in this case, this is not a order derivative inside the transcendental function. These are just y and x. So this is valid. Okay, this is applicable. So in this case, the order is 1 because we just have the first order derivative. Okay. So it's clear to everyone. So next topic is the solutions, or you can say methods of solving differential equation. So can you name me some of the methods how to solve it? Yes. Separation of variables. So that's the first method which we'll do right now. Separation of variables. Next one. Homogeneous equation. Making the equation as a homogeneous equation. And the other, we also had one with integration factor. You remember? Right? So first we'll start with the separation of variables. So what happens in this case? It's a very simple one. If you have m, let's suppose m into y plus n into x is equal to 0. If you have an equation like this, where m is some function in x and n is some function in y. So what will we do in this case? Separate the variables, right? So we take all the terms containing y on one side and all the terms containing x on one side, right? No matter which term is going where, it doesn't matter. So fx upon x is equal to minus gy upon y. What we'll do after this? We'll integrate both sides. Okay, and that's how we'll get the answers. So let's start with some simple questions in this case. First one is 1 upon x dy upon dx is equal to 1 upon x square plus 3. So it's a simple one, right? One upon x dy upon dx is equal to 1 upon x square plus 3. Done? What is the answer? Y is equal to plus constant. Okay. So are there any terms containing y over here? No. All the terms are containing x. So we'll take all these terms on one side. So we get dy is equal to x dx upon x square plus 3. Right? And then what we'll do is integration on both sides. Okay. So what is the integration of y? dy? This will be just y. How to integrate this one? We take x square plus 3 as some function u, yet x square plus 3 is equal to u. So 2x dx is equal to du. Right? So x dx is equal to half du. Okay. So we get integration of half du upon u. So integration of this is half ln u. So y is equal to half ln u. Right? Or we can write, we also have a constant over here, plus c. You can write the constant on either side. Either you can write the constant here or here. But you need not write the constant on both sides. It is clear? Right? So this will be 2y. Let's suppose I put the constant over here. It will be easier. Plus c is equal to ln of u. Okay. So we can shift this equation in exponent form from logarithmic form. Easy to do. So it will be u is equal to e to the power 2y plus c. Right? So what is the value of u? X square plus 3. So x square plus 3 is equal to, now e to the power c is a constant. I can separate it and it can be written like this, k times e to the power 2y. So most of the times in such questions, the solution is not given in the logarithmic form. So that's how you convert it into the exponential form. Okay. This plus c will be converted into a constant which is getting multiplied with e to the power 2y. Clear? Okay. So write down the next one. Next is 1 minus x square into 1 minus y square. Okay, just y dx is equal to xy 1 plus y dy. So can you separate the variables? It's easy. So everybody is aware of partial fractions. I think you'll get a very basic partial fraction over here. So if we shift all the terms containing x on one side, we'll get 1 minus x square upon x dx is equal to y times upon into, okay, this part is very easy, right? So we'll get 1 upon x minus x dx. Just rewrite this part to create a very simple thing. Like, let's suppose I want to introduce a denominator over here. How can we do it? I can write it like this: 1 minus y plus 2y. This is valid, upon 1 minus y, which gives us y plus 2y square upon 1 minus y. Okay, integration of this is possible. Any idea? Dividing by 1 minus y upon 2y square. Okay, any other idea to simplify this? By opening the bracket and dividing it by, so we already have a 1 minus y over here, so this will become y square plus y, then okay, so y square plus y upon 1 minus y, then like this, 1 plus divide by y. Okay, let's see some other way. Now we have a 2y square upon 1 minus y. What we can do is, can we write it like this: 2y square minus 1 plus 1 upon 1 minus y. I think this will be simpler, right? So next step will be, now see, why did I do it like this? Because if we introduce y square minus 1, I will get two factors, y minus 1 and y plus 1. One factor will cancel out. Y minus 1 and 1 minus y with a negative sign common, we can cancel these out. And then we'll get a separate term which is 1 upon 1 minus y. And that will make things very easy. So this is simple integration. So 1 upon x minus x dx, this will be equal to y minus 2 times y plus 1 plus 2 upon 1 minus y. Any doubt? No? So we have y and 2y over here. We can simplify this also. This was minus 2y minus 2, right? I can write it as minus y, because y minus 2y will be minus y. So this is a final thing which you are getting. Times, we also have a dy over here, okay? Now the next step is very easy, just integrate both sides. This step is clear? No? You have a doubt? Okay. So just integrate both sides. Now, what is the integration of 1 upon x dx? ln x. Integration of x dx. Integration of this. Yes. Plus or minus? Minus 2 times 1 minus y. And we'll also get a constant plus c. Okay. Next step, take all the logarithmic terms on one side, add all such terms on other side. So we'll get ln of x into 1 minus y square. This step is clear. If we add 2 times ln 1 minus y over here, then this property will apply. Ln a plus ln b is equal to ln a plus b, ln ab, right? So if we have 2 times ln b, it will be ln b square, right? So that's what I did over here, is equal to x square minus y square upon 2 minus 2y plus c, right? So you can end the question over here. So this is clear? Any mistake? No? Next part. Next question is, find the solution for differential equation xy plus x plus y plus 1 times dy is equal to dx. xy plus x plus y plus 1 times dy, so this is a whole bracket, is equal to dx. So is this the third question for the separation of variable, or fourth one? Third one. I think it's comparatively simple. Done it? How? Taking x common, then? Yeah. So we can simply make factors, 2 factors out of this, right? How? If we take x common from the first two, we'll get x times y plus 1 plus 1 times y plus 1 into dy is equal to dx. So this becomes x plus 1 into y plus 1 to dy is equal to dx. Next step, x will separate the variables, separating the variables of y on one side, y plus 1 dy is equal to dx upon x plus 1. Integrating both sides, integration of y plus 1 is y square by 2 plus y is equal to natural log of x plus 1 plus c. This is the answer. Okay. Clear? Right, the next question. Y minus x dy upon dx is equal to a times y square plus dy upon dx. So it's a bit tricky. So what was the answer for the previous question? y square plus plus y ln x plus 1 plus c. So the answer is given in some other form. I'll show you how to make it in that form. We can write this as y square plus 2y upon 2 is equal to ln x plus 1 plus c, right? And I can multiply this 2 over here. So I'll get 2 times and 2 times c. Okay. Now see this step very carefully. Since we have a constant over here, now it doesn't matter if I take a 1 out of this. Like this is y square plus 2y, and this is reminding me of the identity which is a square plus b square plus 2ab, right? So we have the a square term plus 2ab term. So if I just get a 1 over here, I can get an identity over here. So if I add 1 on both sides, so I will get y plus 1 whole square is equal to 2 times ln x plus 1 plus, let's say, some other constant c. So we can alter this constant c, that's no difference, but we have to see how simple we can make the solution, or how many manipulations we can do in the solution. So if you see a final answer like this, so that's how you have to reach at this answer. Okay. So you have to check very carefully in how many ways you can manipulate this answer into something new. So it is clear to everyone? Done? This one. Okay. What are you getting? But you need to have a y square. This will be in the denominator, no? This will be in the denominator, no? Right? Got the answer? What is the answer? ln of a minus y. So aren't all the terms in ln? They are all in ln. So if all the terms are in log, I think you can make the whole equation without log also. Right? Just try to do that. So let's start. So let's take all the terms containing y on one side. So we get y minus ay square is equal to a plus x times dy upon dx. Okay. Now what to do? Take dx over there, right? This dy and dx should always be in the numerator, so that if you integrate, it is possible. So we get dx upon a plus x is equal to dy upon y minus ay square. How will you integrate this term? Partial fractions? Yes. So just try to convert this into partial fractions. This will be dx upon a plus x as it is. This is integration of, this can be written like this. Let's solve this over here. 1 upon y minus ay square. This is equal to 1 upon y into y minus a. Do we also have a, yeah, this is a times dy. No, this is correct. Okay. How? No, this is 1 minus ay, right? Okay, sorry. So this is 1 minus ay. So how will you simplify it? A into, okay, that you're doing partial fractions. Let's see a simpler way. So what if I introduce 1 minus ay plus ay in the numerator, right, upon y into 1 minus ay. Okay, just try to make denominators in the numerator, right? So we have 1 minus ay over here. I'm writing 1 minus ay. Now see, we have a y over here. So if I write ay, so this will cancel out, right? Which will give you two partial fractions, which are 1 upon y plus a upon 1 minus ay into dy. This is clear to everyone? Just try to make the denominators in your numerator term. Okay. This is natural log a plus x. Next one is natural log y. And the next one, a times, will we get a over here? I don't think so. If I take it as u, this will become du, right? Okay, I'll do it separately over here. If we have integration of a dy upon 1 minus ay, if I take this as u, so this will become du. So we are getting minus du upon u, which is equal to minus ln u, right? So we're not getting any a terms outside the logarithm, minus ln of 1 minus ay plus constant, right? So we can write it as ln of y is equal to ln of a plus x into 1 minus ay plus c. No difference. Can we get rid of the ln from here, from the natural log? How? So we can convert this third term also in the logarithm form, right? So we'll write this as ln of y is equal to ln of a plus x into 1 minus ay plus ln of k, right? Now this is ln a plus ln b, which is equal to ln of a into b. So we'll get ln of y is equal to a plus x into 1 minus ay into a constant k. So now we can compare the quantities inside the log, which will give you y is equal to k times a plus x into 1 minus ay. This is clear to everyone, right? So just try to make the solution more presentable, right? Now this will look very tedious to us. We have 3 logarithms over here, but in this case we got rid of all the logarithms and converted into algebraic form. Write down the next one. So it's a very strange question. Just see it. We have dy upon dx plus 2 is equal to dy upon dx plus 5. Can you tell me the solution for this equation? Does the solution exist for this equation? No? Just think hard. What? Okay, what will you get then? Okay. Okay. So it's like if we have x is equal to x plus, or let's suppose t is equal to t plus 2. Can we square both sides? And if we square both sides, we'll get t square is equal to t square plus 4 plus 4t, and t is equal to minus 1. But this will give you, if t is equal to minus 1, you will get, what will you get over here? Minus 1 is equal to plus 1, right? We can't square because we can only square, and this will equate by squaring even if we have plus 2 over here and minus 2 over here. These are not equal at first, but if we square them and then you root them, right, then they will become equal. Now this is not a good step, okay, by squaring both sides. But you can see that this cancels out, right? You get dy by dx is equal to dy by dx plus 3. Okay. Is this possible in any case? What should be the value of dy by dx in this case? Can it be 0? Can it be infinite? Think. It can be infinite, right? When can the value of dy by dx be infinite? So what should be the value of dx upon dy in that case? dx upon dy should be equal to 0 in this case. Can you tell me the solution for this equation? X is equal to constant, exactly. So the solution for this equation will be x is equal to constant. So by looking at it the first time, it seems that this is a very strange equation, right? So this will cancel out, dy by dx also cancels out, right? But the solution for this one will be dx upon dy is equal to 0. Since this will be equal to 0, this will be a very large terms, right? So if we add 3, that will make no difference. So can you tell me the curve for this equation? So how will you get the curve? It will be a straight line parallel to which axis? Y-axis. So this will be the constant, and this is the equation, x is equal to constant. Okay. I think we can do one more question. Okay. So it's a simple one. Find the differential equation of the family of circles having centers on the x-axis. Let's suppose the center is or radius is constant. Center is on the x-axis and radius is constant. So center is on x-axis, it will be of the form h comma 0. And let's suppose the radius is r. So what will be the equation? X minus h whole square plus y minus 0 whole square, which is y square, is equal to r square. Next step, differentiating both sides. So we get 2 times x minus h plus 2y dy upon dx or y dash is equal to 0. Right? Next step, we have to differentiate it once more. Right? So differentiated, what do we get? So we can do it like this. We have 2x plus 2y y dash is equal to 2h. Taking the variable on one side, right, and the constant on the other side. Differentiating, now we get 2 plus, I can cancel the 2 also. 1 plus y dash square plus y into y double dash is equal to 0. So write it in differential form. We get y d2y upon dx2 plus dy upon dx to the power 2 plus 1 is equal to 0. So what is the order of this equation? It will be 2 and the degree 1. Okay, clear to everyone? Okay, thank you.